Welcome to Maths and Science Unpacked. We are continuing with our lessons. For those of you who have followed our previous lessons, you would have realized that I pay a lot of attention to terminologies. I pay a lot of attention to terminologies. Why? Because it is very important. Most of the questions you will encounter in your maths program, you will need to understand certain terms that are used to describe questions, to describe concepts, and so on and so forth. So I take time to really explain things. Today, we are going on to a second part of an expansion where we look at more difficult expansions that you could encounter in your high school or secondary school maths. But before we do this, there are some important terminologies that I want us to look in this short lesson. The first one is binomial. And binomial is a very important thing in algebra. You will encounter a lot of it throughout the course. But let's break down this word binomial. Binomial, as we would expect, is from a Latin origin. Bi means two. Nomial means term. Therefore, binomial is an expression, an algebraic expression with two terms. Okay, binomial, two terms, as simple as that. Now, let's look at examples of binomial. S plus 3. Now, let's try and unpack this. S is a term, plus 3 is a term. And these two, because it is an expression made of only two terms, it is a binomial. Okay, now let's look at another example. 2s squared minus 4. Again, this is a binomial. Why? Because we have 2s squared being one term and 4 being another term. The binomial will usually be separated by a plus or a minus. It doesn't matter. Technically speaking, we say that binomial is the addition of two terms. Addition of two terms. Okay, but when we say addition of two terms, it's still valid for an expression like this. And what do I mean? The first term is 2s squared plus the second term is negative 4. And when we resolve this, or when we simplify this, we end up getting 2s squared minus 4. So binomial is indeed addition of two terms, okay? And adding a negative term to a positive term will ultimately make it a negative sign between the two terms. So that is why we simplify the definition of binomial to mean the addition of two terms. Once we know what a term is and we are able to put two terms together, we get a binomial. Having said that, let's look at something more. Sometimes we want to go overboard. We want to go beyond ourselves, so we try to complicate things. So for instance, someone will come s plus 3 minus y. Is this a binomial? No, it is not a binomial. Why? It has more than two terms. This is one term, this is another term, this is another term. This has three terms. No matter how simple it looks, it is not a binomial. Strictly speaking, it is what we call a trinomial. Okay, following the root word following the root words, we can say that this expression will be a trinomial. Okay, 3 terms. Okay, but beyond 2 terms, we normally simplify and group any expression with more than 2 terms as polynomial. Okay, polynomial. So further on in your mathematical journey, you may come to what we call polynomials. Okay, expression with many different terms, usually more than 2 terms. So whether trinomial or whatever, they are all classed as polynomial. So we know what binomials is, and we know the root word for binomial, and we can explain that. Now let's look at some more examples, and let's put things in proper context. You remember when we started our lesson in algebra, we tried to define what a constant, a variable, a term, expression, and so on, what they are. Now, we said that a term can be as simple as 3. A term can be as simple as s. And then a term can be as complicated as 3s squared y cubed z. All these are examples of terms. So long as they are together as a unit, when different variables are multiplying themselves, or when a coefficient is multiplying different variables, they still remain a unit. It only becomes separate when we have a plus or minus and then something else. So this will ultimately become an expression. But without addition or subtraction of anything, it remains a term. Okay. Now, following on from here, one may argue, therefore, 2 plus 3 is a binomial, isn't it? Because 2 is a term. 3 is a term. They are separated by a plus, so it's technically an expression made of only 2 terms, and so this qualifies as a binomial, strictly speaking. Okay, it is a binomial. But in maths, and for that matter in algebra, usually when we are talking about binomials or polynomials, we are more focused on terms that have variables. And therefore, we may typically find a binomial to be s plus 3 or 2s minus 3y or 4 plus 3y. Okay, so strictly speaking, a simple expression as 5 minus 6 is a binomial, but in algebra, we would usually focus on binomials where we can find a variable, because remember, after all, algebra is typically trying to sort out a variable. Okay, so that is it. We know what a binomial is, we know the root word, we know what is not a binomial, and we know what technically could be a binomial, but we usually don't consider it as such. So that is the first part of this lesson, and it's very important that we understand some of these things so that we will be able to build on as far as going through algebra is concerned. Thank you. Having talked about binomials, it is important to look at another interesting concept in algebra. Normally, you will get to expand 2 different binomials at a time. If you recall our lesson on expansion, we will normally have a very simple expansion like this. Okay, where you typically had one term sitting outside the bracket and then you are asked to expand over. And you can play back the video on expansion and see how you go about this. But this one typically means that the term sitting outside the bracket goes for each of the terms sitting inside the bracket by way of multiplication. So this becomes 10s, and then this becomes minus 5sy. So that is the expansion. How about when you have two binomials to expand? 3 minus s, 2s plus 4. Okay, so this is a binomial. This is a binomial in a bracket. This is another binomial in a bracket. And we are meant to expand this. What happens? Now, let's look at something interesting. When you have the same variable in two different binomials and you are expanding them, it results in something that we want to briefly talk about. We will come back to this. But let's look at an expression, a kind of expression in algebra where the highest power of a variable is 2. It's very interesting. You know what I'm talking about. We will come back to the expansion, the difficult expansion examples. But let's look at what we call quadratic expressions. Okay. A quadratic expression is an algebraic expression, okay, where the highest power of a variable is 2. Okay, but quadratic expressions go beyond this simple definition of where the highest power of a variable is 2, because you can have a very tricky expression that looks like a quadratic expression, but it doesn't satisfy all the criteria. And it will be very difficult to attempt to solve it as a quadratic expression. Okay. For instance, if I give you a random expression like 3s squared minus 2, 3s squared minus 2, and then I tell you to try and solve this, it looks like a quadratic expression. Why? Because the highest power of the variable s is 2. Okay, but let's look at what typically a quadratic expression is. For something to be a quadratic expression, it must satisfy 2 other criteria apart from the highest power being of the variable being 2. So what are these 2 other criteria? First of all, a quadratic expression generally is in the form a s squared plus b s plus c, where a, b, and c are numbers. Okay, and numbers attached to variable, if you remember from our previous lesson, are coefficients. Okay, so when we are talking about a quadratic expression, strictly speaking, we are looking at an expression in this form, the form in the black box, where the highest power of the variable is 2 And then there is another kind of variable which is similar to the highest power but not up to 2. Okay. And then there is another number attached to it. A typical quadratic expression will satisfy this criteria. The second other criteria is that the a can never be equal to 0. Okay. Once the a is 0, all this is wiped out. We no longer have the highest power in the expression being 2, and so it's no longer a quadratic function or a quadratic expression. So that is an example of quadratic expression. And quadratic expression results from expanding two binomials where there is a common variable. What I mean is if I have 3 minus s and I'm asked to expand this over 2 plus 3s, the common variable here is s. The common variable here is s. It is a binomial expansion, and this will result in a quadratic expression. Good. So two things that we wanted to learn in this lesson quickly. We learned about binomials and look at it in detail. And then we see what happens when binomials become quadratic expressions. Now let's go on to look at how we expand these more tricky expressions, some of which may result in quadratic expressions, some which may result in even more complex expressions. But we now want to take the expansion to another level. So let's watch out that in the video titled Expansion Part 2. We've already done expansion, a first video. The part 2 will take us into this. Thank you.